So good day guys, today we'll be talking about stoichiometric in chemistry. Actually, stoichiometric is brought out from two Greek words, and those two Greek words are stoichio and metric. Stoichio means element, while metric means measure. So the measure of element. And what are we measuring here? We're actually measuring the kind of element or compound that is being consumed and the kind of element or compound that is being produced in the product side. So in stoichiometric, we are not to focus on every element or every compound in that chemical equation. We are just to focus on the kind of element or the kind of compound that asks you to measure. These are the things we are going to measure, and we are going to relate ratios, the ratio of these elements together to get our final answer. So let's move on to today's questions in this video. The question says the number of molecules of carbon dioxide produced when 10 grams of carco-3 is treated with 0.2 dm cube of 1 molar of HCl in the equation is what? They give us the equation there. Now, what are the elements that we are going to focus on? Now, the first element that they ask us to focus on here that we are looking for the molecules is the carbon dioxide. So we are focusing our attention on carbon dioxide first, and then they said we should focus on our attention on carco-3 because they give us the mass of carco-3, that's 10 grams of calcium triacylcarbonate. So we are focusing our attention to on carco-3. Good. And they didn't stop there. They also made mention of HCl. They give us the volume and the molar, that's the concentration of HCl. So they asked us to concentrate on these two. So how are we going to solve this question? The first thing is to write out the mole ratios. 1 mole of CaCO3 from this equation will give us 1 mole of CaCO2, and for this, for HCl, 2 mole of HCl is going to give us 1 mole of CO2. Looking at these two, we can see the one that is actually very closer to CO2 is carco-3. So I'm going to be using carco-3 first, and I would advise you to, whenever you're actually relating, choose the one that is very close to the quantity that you are looking for. I choose carco-3 because they are having the same number of moles. So any number of moles I got for carco-3, it will be very easy for me to get the same number of moles for what? For the CO2. So let's move on, guys. So now, getting back to the CO2. Good. So the number of mole of CaCO3 here, I'll give us the same number of mole of what? Of CO2. Now, don't forget that number of moles is equals to mass over molar mass. Mass over molar mass. Now, what was our mass? The mass of CaCO3 they give us in this equation is what? Is 10 grams. So it will be 10 over carco-3, that's calcium triacylcarbonate. Carbon is 40, calcium is 40 plus carbon is 12. Carbon is 12 plus our oxygen is 16. So it will be 16 to multiply 3. Good. So finally, we are going to have 10 over, if I calculate everything, I'm going to have 100. I'm going to have 100. So since I'm having 10 over 100, so my n is equals to 0.1. So 0.1 mole is the number of mole of CO3 according to the number of mass they give us there. So since our number of mole is equals to 0.1, our number of mole of CO2 will also be 0.1. Why? Because the mole ratio according to this equation is 1:1. So anything I have for calcium triacylcarbonate, I also have it for what? For CO2 in terms of what? The numbers of moles. So I'm going to relate the number of mole of calcium triacylcarbonate to CO2, which is also equal to what? 0.1 mole according to the equation that they gave us in this particular equation. So good. So since my number of moles is 0.1, so n, so my n, good, so my n is equals to 0.1. Good. Okay, and another equation for number of mole, n is equals to number of molecules number of molecules number of molecules over Avogadro's constant. Good. So my number of mole is 0.1, which is equals to, they ask us to look for the number of molecules, so let's make this x. So to be x divided by our Avogadro's constant is 6.02 to multiply 10 raised to power 23. 10 raised to power 23. Good. So with this, that shows that our x is then going to be equal to 0.1 to multiply 6.002 times 10 raised to power 23. Good. That's 10 raised to power 23. So with this, our x is equal to 0.1 is same thing as 10 raised to power minus 1. And 10 raised to power minus 1 plus 23 is going to give me what? It's going to give me 22. So it will be 6.02 times 10 raised to power 22 molecules. So this is my answer for the number of molecules, and that's option C. So option C is correct because x is equal to 6.02 times 10 raised to power 22. But some might be saying, can't we use HCl? Yes, you can use HCl and still going to get the same answer. But for jam students, very easy for you to just use this calculator to get your answer and you are good to go. But let's check if HCl is still going to give us the same answer. So let's look at that. So in the question, they give us the number of concentration of HCl. They give us the number of concentration of HCl, and they also give us not only the number of concentration, they also give us the volume. And don't forget that before I start looking for the number of mole, let me write the mole ratios in this equation. So the mole ratio for this equation, according to HCl and CO2 is 2:1. That means the number of mole of CO2 is multiplied by 2 to get the number of HCl. We relate that later, but before we relate it, let's get the number of mole of HCl. N is equals to Cv. They give us the C in the equation. Our C is equals to what? 1 molar. That is 1. Times our volume is what? 0.2. So our final N is equals to what? 0.2 moles. So gotten this, let's now relate it. If 2 of HCl we give 1 of CO2. Good. Yeah. If 2 of HCl we give 1 of CO2. Good. HCl. We give 1 of CO2. Then 0.2 of same HCl will now give how many of CO2? Don't forget, this number of mole that we look for is actually for HCl. So if I cross multiply, my x will be equal to 0.2 divided by what? Divided by 2. So my number of mole for CO2 will now be equal to what? 0.1. So you can see I've gotten my number of mole for CO2. So after getting the number of moles of CO2 using the same formula we get, don't forget the number of mole for CO2 that we got in the other one too was 0.1. So using the same formula too, we are still going to get the same answer. So let me rub up this so we can get the number of moles. So don't forget that number of moles is equals to number of molecules over Avogadro's constant. N is equals to number of molecules number of molecules. So our number of molecules over Avogadro's constant. Good. So our number of mole is 0.1, which is equals to, let's say this is y, over Avogadro's constant is what? 6.02 times 10 raised to the power 23. So eventually my y will be equal to 0.1 to multiply 6.02 times 10 raised to the power 23. Yes. Good. Okay. So with that we have, yes. So with that we can see that 0.1 to multiply 10 raised to the power 23 is going to give us 10 raised to the power 22, because 0.1 is same thing as what? 10 raised to the power minus 1. So eventually my y will be equal to 6.02 times 10 raised to the power 22. Good. Which is our option what? Option C. So 6.02 times 10 raised to the power 22. That's our answer according to this. So no matter what you use, you are still going to end at the same answer. So the major thing here to look at is look at the one that is actually closer to the one you are looking for, the quantity you are looking for. You have to quantify the two. Write the mole ratios, look for the number of mole of one, and use it to look for the number of mole of the one you are looking for. Then use the formula that tallies, so you can get what they ask you to look for, the quantity they ask you to look for. So that's just that for today. Subscribe to get more of this. I'll be doing the part 2 of the stoichiometric in the next class. Thank you so much.